Okay, hi everyone, welcome to the last class of the database course. So today we don't have much materials to be covered. We will be mainly focused on introducing the final exams. According to the schedule, we will have the final on next Monday. And the format I plan to do will be very similar to midterm. We plan to do the final as a take-home exam. I can grant you the 24 hours to finish the final exam. And I will release the questions by the Sunday midnight. And you should submit the answers to Canvas by the Monday midnight, and I will introduce more information later. So in this year, due to the pandemic, we teach this course in a very different format. Compared with the previous years, we do this online learning, and I post videos, and you watch the videos, and then follow the lectures, and to learn these database systems. I know this is a very different format for you, and it's also very different for me as well. And during the process, I also find some problems. Online learning is still very different compared with this online face-to-face learning. Normally, during the face-to-face lecturing, I can see the expression of the students and then deliver my lectures. However, for the online learning, it's very different. I just try to cover the materials, and I also hope to get some feedback from the students. However, it seems you don't prefer to send me emails to ask questions or come to the office hours. It doesn't matter. You have different preferences. It's okay. And I also just check the videos we have been posted in this semester for the lecture, and I also count how many videos we have been posted. I think we have posted about 148 videos already. It's a large number. If we also consider videos for the midterm and final, it will be about 150 videos. And if you do watch the videos and also follow the lectures, I think you should be able to learn the database system in a very good way. However, I also check the view number. For many of the videos, the view number is about 1/3 of the class size. It should not happen, right? Because you should watch the videos so you can follow the materials we cover in the lectures. And all this knowledge are very useful for you, actually. I think if you do spend some time on this course and with the project, you will learn lots of useful knowledge. Normally, after this course, you should be able to implement most of the websites you have seen in your life, right? If you plan to do some websites similar to Amazon, Facebook, you should be able to do now after we take this database course, because you have basic skills already to implement anything you plan to do on the web. So I know some of the lectures probably cannot meet your expectations because it's also my first time to do it. Before, I think it should be very easy because I watched also online courses, the book. And I think it should be very easy to do this kind of lecturing. However, later on, as I do these lectures, I find it's very hard to do this video recording, editing, and uploading. These kind of things, it takes lots of time. You can also see we have different paces for different sections. Before the midterm, we do the lectures for the design part in a very slow way. We introduce in very details for the ER model, relational design, relational algebra, and essential. We introduce these kinds of knowledge in a very slow way because it is a beginning for this course. And after the midterm, I think you should be able to intro this course. Therefore, for the sections on the SQL, as well as indexing and crash recovery, we cover the lectures, we cover the materials in a faster way. So it may be challenging for you to follow. However, it is a required skill for you to do this kind of learning because you are into this course already, and you should be able to learn this course as you master some basic knowledge and can follow these ideas we cover in the lectures. And I also receive emails from students asking questions about the projects. I remember I have shared with you some of these online tutorials on programming. So if you follow these tutorials, you should be able to implement your website in a very fast way. I remember in the tutorial, the poster has introduced one framework. It's called Django, right? Even though it is in Python. With Django, you can implement lots of websites in a very fast way. It's very convenient to use. and you can only handle this connection between the web interface versus this database backend in a very convenient way. So there should be no problem with the programming part if you do watch the tutorials we posted before about the programming part. So I really hope you can learn some basic useful knowledge from this course. And besides this section we cover in the lecture, I also suggest you read the textbooks for the remaining sections as well, because besides the materials you covered in the lecture, there are also lots of other knowledge in the textbooks which are very useful and also necessary to learn about database systems. Okay, so this is about what we have done before, and let's come back to the final. Okay, so let's talk about the final exam. So we plan to do the final exam very similar when like the midterm. We will do the final as a take-home final exam and within 24 hours. The time for the final will be on Monday, from the midnight of Sunday to the midnight of Monday. I mean, the time will be in the EST. And I will send you the questions about the final exam at a Sunday midnight, I mean December 6th. And you need to submit the solutions answers by Monday midnight, I mean the midnight of December 7th. And all the submissions will be in one single PDF document to the Canvas, and no later submission will be accepted because we have 24 hours and you should be able to finish all the questions with the one day, right? Originally the final exam will be about 2 hours. Now you have 24 hours. It should be enough time for you to finish all the questions. And the final exam will be closed books, closed notes, but you can prepare one page of the cheat sheet, and the cheat sheet will be in A4 size, double side. You can also plan your strategy well for what to be right on the cheat sheet. As to the submission will be in one single PDF document to the Canvas, which should include both your answers to the questions. So you can print the final exam these question papers and then write your answer on the paper and then scan it. And you can also scan your page of this cheat sheet as well and then combine them into one single PDF document to be uploaded to the Canvas. I think the link has been created for you to upload these answers. And we have some basic requirements for the final. It will be based on the individual work, no discussions, no cheating, no answer checking or exchange among your peers or friends, no calculators or other electronic devices, laptops, iPads, smartphones, and etc. They are all prohibited. Any form of cheating on examination will result in a 0 grade and will also be reported to the university as well. At the same time, if you observe others and one other cheating, and welcome to report to me, and I can give you some bonus if these kinds of cases are confirmed. Okay, so these are requirements for the final exam. So you know the final exam will take about 35% of your final score, so it's very important. And the topics to be covered in the final actually includes all the materials we taught in class as well as on the textbooks, except this web-based DB programming. So for all the materials, I mean from the introduction to the latest crash recovery, these sections, they will all be covered in the final exam. As for the format of the final, we will have different kinds of questions prepared. We will have a set of true or false questions with brief explanations. Like we have some questions prepared for you to ask whether it is true or false, and you also need to provide the reason why it is true or false. We can provide you with the example, like any relation in pseudo-normal form will also be in BC normal form as well. Is it true or not? Now if you say the answer is false because some reason, you need to write down the reasons down in a brief way. We will also have some short answer questions, like we can ask you what is the undo login, and how to use this undo login for crash recovery, as well as what is the difference between undo versus redo, and how to use them for the crash recovery. Some questions like this. Besides them, we also have some more questions prepared for you, like for the normal forms, we have some questions prepared for you as well as for SQL, for relational algebra. So the total points for the final exam will be about 100 points. And I should be able to have enough time to finish all the questions because we have 24 hours. It should be enough for you, right? We have some suggestions for you to prepare for the final. Please go over this lecture slides carefully and also study the textbooks very carefully. Work independently on the problems in both homeworks, lectures, exercises in the textbook. And you can discuss with the people in class or contact me and the TAs if you have any questions when going over these materials. I would like to suggest you to practice this question or some problems by yourself before the exam, because practice is necessary for you to do some questions, right? And you can work some questions or problems out by yourself before looking at the solutions, and then check back the answers to compare what part can have some problems or can have some issues there, and then you can focus on these kinds of parts. Because we have so many materials to be covered in the final exam, you need to schedule your time well. It is important. As to the topics or material to be covered, we will cover all the materials from the introduction to the crash recovery, all the sections. I can go over this section for you briefly. I hope you still remember, right, in the introduction we asked you what is the database system and why we have to use database system for our applications. So beside the file system and the operating system, why we should have another system called the database system, right? And we provide you with the reason why the file system or the operating system is not enough. We have some special requirements for handling data, right? And also compare with some other programming, right? So data processing may require some ad hoc programs, and we may require some generalizations for sorting, for file maintenance, as well as report generation. Then we need to have the database system to help us. If you still remember in the introduction, we show you a diagram for the database system. It's architecture, right? So normally for the database system, we have different kinds of users. These end users or the web forms as web application or DBA. I think after you finish your project, you should be able to know, right? Besides the users who type in the queries, and these applications or the web forms, they can also send queries to a system as well. And once a query comes in, we need to have different components to handle it in the database system. We have a query parser, the query writer, query optimization, and the query executor, right? And they will be operating based on both the records. These records denote the tuples we have in the database system, right? As well as indexes. These indexes denotes the tables we create for speeding up the query process, right? We also have this buffer manager, right, as well as storage manager, because the database system is still software running on a computer. We have some managers to handle both the buffers as well as storage space. And DBMS is running based on some storage space. It will be the hard drive or the disk, right? They can store all the data we have, covering the concrete data, the metadata, the schemas, indexes, and logs, and etc. Besides the queries, we can also have different kinds of inputs like the transactions. If you still remember, right, transaction denotes the execution of some applications. When the transaction comes in, we need to have a transaction manager to handle it. And we can also accept the data definition language commands, and we can also have a processor to handle these kind of commands as well in the system. We need to have a concurrency controller, right, in the system, because we can accept different kinds of queries transactions operating on the same data. Actually, we need to control this concurrency operating on the same data, right? Besides, we need to have a login system as well as crash recovery components for handling the crashes we can have in the system. And everything will be running based on the memory, right? In the memory, we have the buffers. We can store data, indexes, logs inside it, and we can also have some log tables as well if we need to control some concurrency, right? Okay, so this architecture is very important, and it can provide with a big picture about database system. And we have also mentioned so many different people in this lectures, right? And they all contribute a lot to the database system. I hope you still remember their face as well as them and their contributions. And because of their great achievements, we will be able to use the database system for handling data nowadays. And we definitely need to have more people contributing to this area, and maybe the next one will be you, right, behind the scene, contributing to the database systems. This is for the introduction. The next topic we have covered is called ER model, right? If you still remember the ER model, we drew some basic diagrams, and we have lectured about how to represent the entities, attributes, relationships, as well as constraints many-to-one, one-to-one, many-to-many, as well as roles in the relationships. We have also mentioned subclasses, right? If you still remember, we use the triangles. And we have different constraints in the YAR model, the keys, the referential integrated constraints, and etc. We also mentioned the working states, why we need to use it, and how to represent it, right? And we may have some questions for the YAR model. Now, given a real-world application, we plan to borrow it into a YAR model, how to represent it. It is important. It is also the beginning for the database system designing. After the YAR model, we move to the relational model, right? We translate everything into relations. Relation is the only concept in the relation model. And we mentioned schema versus instances. I will still remember, right? We'll compare the schema versus instances with this class versus objects in programming courses, right? We'll mention the language to process them, the DDL and DML. I will still remember the full name for these two different languages. We'll mention the primary key, foreign key, unique, null, and default as keywords we can use in the relational definition. We cover lots of rules for translating the YAR diagrams into relations for both entities, relationships with many-to-many, many-to-one, and one-to-one. They will be slightly different, right, if you still remember. And we'll mention how to translate the working states into relations as well as subclass. And we may have some questions on this given a YAR diagram, how to translate it into a set of relations, what are the primary key, foreign key, and how to define them into SQL. After the relational model, we move to the relational algebra this section. This provides a theoretical design of the query language we need to have for operating on the relations, right? And later on, the SQL will be based on the relational algebra we learned before. In the relational algebra, we cover the basic information for operators, operands. We have introduced the set-based operators, I hope you still remember, and some other basic operators and the derived operators, right? And we have also mentioned the product between two relations, and based on product, we can further define theta join, equijoin, and natural join. I hope you still remember them. And we also mentioned how to represent the relational algebra expressions. We can either represent them into a known sequence, right? Or we can divide them into several sequences, several rows, or represent it as a tree, actually. And we may have some questions for this section that given a database or relations on the queries using relational algebra. We need to use the selection, the projection, as well as this kind of product and joins to define or write down these relational algebra expressions to answer these queries. Then we move to an important section for the relational design. I hope you still remember this section. This is very important. We spend lots of time on this section. We mentioned the motivations why we need to have this section, because the relation we have we can get from the relational model after translation may not be perfect, and they may have some problems, especially for the redundancy, right? And we want to reduce the redundancy and at the same time not harm the query efficiency. Therefore, we need to refine these relations, and that's the reason why we need to learn this section. I always remember in this section we spend lots of time on introducing this functional dependency, right? And as well as the keys. We mentioned the Armstrong axioms and also the closures of both attributes as well as functional dependencies. Based on them, we further introduce the normal forms as well as the decomposition algorithms. We focus on the basic normal form, right, as well as certain normal form. And you also need to remember their shortcomings, either lossless or lossy, as well as functional dependent preserving or not for these different normal forms. We have a suggestion for this section, right? Don't overdo this kinds of refinements, because some of the normal forms will divide the relation into pieces, which are very small. It will create lots of problems for the later on queries, because we have to join them again together, right? It will be time consuming. So don't overdo it. For this section, we may have a question like this: given a relation and a set of functional dependency, decompose it into basic normal form or certain normal form. So then we have the midterm, right? And after midterm, we have the sections on SQL. So you need to know what is SQL and why we need to learn SQL, and what is the DDL and DML in SQL. I hope you still remember the template we can write down the SQL queries is select from where, right? And we have mentioned the string pattern matchings and write the pseudo-value logic to decide true, false, or unknown values for some logic explorations. We will mention some queries. It will be very useful for you, right? Especially if your query is very long and very complex. And then we mentioned the aggregated queries. We have set from where, group by, having, right? I hope you still remember these different keywords, right? And this where, having, they're very different, even though they both denote some conditions. And then we mentioned the constraints, right? The keys, the checks, the assertions, and triggers. The triggers are very useful, right? We mentioned lots of examples in the lectures. How to design a trigger, right? Based on the questions. So for this section, we may have some questions like this: give a database system on the queries use SQL. It will be very close correlated with the relational algebra we learned before, right? Then we move to an important section for indexing. For the indexing section provides some basic information for indexes. We mention what are the clustered and unclustered index, dense versus sparse index, primary, secondary index, and sequential index. And we spend also time on the B tree and B plus tree, right? What's the definition of B plus tree and B tree, and how to do the query, insertion, deletion into these kind of trees. And we have different kinds of cases. For the insertion, we have to split some nodes, right? If they exceed the maximum number of keys allowed for the nodes. And for deletion, we also need to do this rotation as well as this mergence, right? For some nodes, if they are below the minimum number of keys allowed for the nodes. And besides the trees, we also introduce these hash tables and hash functions. We mentioned three different kinds of hash tables: the conventional hash table, the extensible hash table, and the linear hash table. They all have different kinds of shortcomings, right? For the conventional hash table versus the extensible hash table. Therefore, we introduce this linear hash table instead. They combine the advantages from the previous two, and they can achieve not so great performance in the real-world applications. So for this section, we may have some question like this: given a B plus tree hash table, and we want to do a search, insert, or delete a sequence of key records from these hash tables or in B plus trees. And finally, we move to the transaction management and crash recovery. And for this section, we mention what is a transaction, right? I hope you still remember. As well, what are the basic properties for the transactions? We mentioned the ACID, right? It represents 4 different properties. And to handle the crash recovery, we provide 2 different techniques we can use, right? The first one is called undo logging. The second one is called redo logging. They are very similar, however, they are also very different. I hope you still remember how it works and what's the difference between them, right? And for this section, we may have some questions like this: given a undo or redo logging, try to recover the system from crashes. How to do that? So these are the basic materials we have covered in this course. I hope you can remember these kinds of knowledge points we have mentioned in this lecture. If you're not, please go back to this lecture and the textbooks to go over these materials again so you can get familiar with them. They are very important. Okay, so these are the materials we have covered. The next page will be about the interesting equation we have showed before in the introduction. Right? I hope you still remember them. So we show the equations in the very beginning for this course. So we have a case, we assume your current potential is 1.0. If you work hard for a day, then your potential will increase by 0.1%. However, if you not, your potential will drop by 0.1%. We provide you with 3 different cases. If a person works very hard 365 days a year, then his potential he can get after the year will be about 1.44, right? In other words, his potential gains by 44%. It's a big gain, right? Another case is the person who plays very hard for 365 days per year, then his potential he can get after the year will be about 0.694, right? In other words, if a person don't study in a year, then his potential will be dropping by more than 30%. The next case will be a person who works very hard half a year and plays hard half a year, then his potential after the year will be about 0.99998. In other words, if a person works harder and plays harder half and half, then his potential will be smaller jobs. I hope this equation can provide you with some insights for planning your time. not just in this course, also for the future, right? Because this course is short, it's just one semester. However, your life is long. You need to find your dream and also work hard on it. Spend your time wisely and never regret for anything you do. Okay, so this is the material we plan to cover for the course and for the final exam overview. And after the exam, you can have a break. So remember, we are still in the pandemic. Please take care and stay safe. Hopefully, we can come back to the campus in the spring the next year and we can meet in person. Okay, so that's it for this lecture. I really appreciate it for your time and efforts devoted to this course. And I also need to thank you for your feedback and questions proposed. If you have any other questions or suggestions, do please let me know. You can send me emails. Normally, I'm very fast in replying to your emails. Okay, I hope you will have a nice Christmas break and winter break. Thanks. Bye bye.